Okay, so welcome to this video. Now hopefully you've already watched the earlier parts of this video where we covered the majority of these topics on the revision checklist. Now we have to make sure that we do cover all of them because of course we don't know the exact topics that are going to come up on the GCSE on paper 1, paper 2 and paper 3. But we can make some pretty good guesses. But this video is going to cover all of those topics that make sure that we get a full coverage. So as you can see on the revision checklist, we have now covered every single topic with the exception of perpendicular and angle bisectors and some loci problems and constructions. So I will link those videos in the description so that you can check out that topic as well. But using these videos now, you will be able to have a practice at absolutely every single topic across this revision checklist. So do make sure you get this downloaded, but we are going to get started with the video. But before we do, let's just have a quick look at the new upgrade program. If you're only going to watch one video this year, this is the one. With GCSE Maths right around the corner, I'm going to show you 3 easy steps to maximise your grade using minimal effort. Step 1. Head to the TGMT hub, go to the bottom of the page once you've logged in and access the revision quiz. From here you can answer a question on every topic within the GCSE. You can go through working through each question and making sure that you practice absolutely everything. Once you've done that, you are going to get a full report that shows you exactly what you got right and wrong on all of these questions. So work your way through the quiz and then access your report. From here you can see on individual units what you need to work on and what you've already secured. So identify what you need to work on. Then we're on to step 2. Head back to the hub. You can go through the units, you can go to the exact one that you know that you need to work on, and you can access all the individual topics within that unit. Once you've done that, you can pick the topics that you want to work on, watch the video, and you can complete a topic quiz for that particular topic. So work your way through the quiz, answer those questions, and then you're going to get another report. That's going to show you exactly what you got right and wrong, so that you know if you need to do any more work. Step 3. Head back to the hub and go to the bottom. You can now go onto the upgrade quiz. On here, you're going to be able to answer questions again, different to the first, on every single topic within the GCSE. Once you've done that, you're going to get another quiz breakdown and a report that shows you exactly what you got right and wrong, so you can put any of those finishing touches in before that exam comes along. With the exams right around the corner, we need to make sure that we make revision simple. Join Upgrade. Okay, so make sure you check out the free trial there. Let me know how you get on. Drop me a comment, see what you think. But let's get started with our paper. So as with all of these papers, you can access the video straight away by scanning the code. So once you've got this printed off and you've had a go, you can always come back to the video at any point and you can use the chapters or the links in the description to access all of the full videos on the topics within it. So looking at this one here, we have got question 1. Put a pair of brackets in each statement to make the statement true. So you need to have a look and think, where could you put the brackets? So you could put it around the 2 times 7 squared, or you could put it around the 7 squared minus 2. If we put it around the 2 times 7 squared, let's just have a look. That would be 2 times 49, which would be 98, and then take away 2 would be 96. That doesn't quite work. So it has to be around these two, but let's just double check. So 7 squared is 49, take away 2 is 47. So that'd be 2 times 47, which is 94. So there we go. That is where we're going to put the brackets for that one. For part B, again, we've got 3 options now where we could put the brackets around the 16 divided by 2, the 2 plus 6, or the 6 plus 2. So let's just start at the beginning and see what we get. If we put it around the 16 divided by 2, we get 8 plus 6, which is 14, plus 2, which would be 16. So it's not going to go around those. So let's try it around the 2 plus 6. Again, the brackets could potentially go around 3 things, but let's just have a look. So 16 divided by, well, in the brackets, we've now got 8. So 16 divided by 8 is 2. Add the 2 is 4. So there we go. That's where our brackets would go. So there we go. There is question 1, some order of operations. Question 2. In a breakfast cereal, 40% of the weight is fruit and the rest of the cereal is oats. So again, we could write next to that straight away that that is 60%. Write down the ratio of the weight of the fruit to the weight of the oats and give your answer in the form 1 to n. So let's first write down that ratio as a percentage. So the ratio of the weight of the fruit, it tells us that 40% was fruit, so that'd be 40% to 60%. Now we can simplify that ratio as far as we can to start with. They both divide by 10, or you could divide them both potentially by 20 or something else, but let's divide them both by 10, so that'd be 4 to 6. They both divide by 2, so that'd be 2 to 3. And then we want it in the form 1 to n. So if we want this number on the left to be 1, what do we have to divide this number by? Well, we'd have to divide it by 2. So if we divide by 2, we also have to divide the other side by 2. And 3 divided by 2, well, you could just write that as 3 over 2. You might know that that's 1.5, and that'd be a fine way of writing it as well. So there you go. You could have divided right from the start. You could divide both numbers by 40, but in that circumstance, you are just going to get a fraction that you're going to need to simplify anyway, potentially, or to be fair, you could have left it as 60 over 40 on the right. It doesn't actually say it needs to be written in its simplest form, but there we go. Good practice writing in its simplest form. So 1 dot dot 3 over 2, or you could write it as 1.5. I don't tend to like writing decimals with ratios because it's just quite a lot of dots everywhere, but there we go. Either answer is fine. It says a different breakfast cereal is made using only fruit and bran. The ratio of the weight of the fruit to the weight of the bran is 1 to 3. What fraction of the weight of the cereal is the bran? Well, the bran is mentioned second, so that's our second number in the ratio there. So whatever the fraction is, it's 3 on the top, out of something. To find the total that it's out of, we just need to add together the numbers in the ratio to see the total. So 1 and 3 gives us a total of 4, so that would be 3 out of 4. And of course, the fraction there for the fruit would therefore be 1 out of 4, but it only asks us for the bran. So there we go, there is writing some ratios as fractions, and we also had some in the form 1 to n as well. Okay, so for this question we are adding fractions. We know when we're adding or subtracting fractions we need a common denominator. So I'm going to rewrite two blank fractions. I'm going to think what's the lowest common multiple of 5 and 4. Now in this circumstance it is 5 times 4, which is 20. But again, we're going to try and look for that lowest common multiple, not just necessarily always timesing them together. Saves us a bit of time maybe if we have to simplify, although this question doesn't say we're going to need to. So to get 20 on the bottom, that means multiplying the left fraction by 4 on the top and the bottom, and the right fraction we are multiplying by 5. So the left fraction, the 2, is going to become 8 as we're timesing by 4, and the right fraction, the 1, is going to become 5. Now we have a common denominator, we can add them together. So 8 and 5 adds up to make 13, and the bottom number stays the same. So 13 over 20 would be our final answer, and making sure we get our method marks there for showing that we created a common denominator, just in case we make a mistake. For part B, it says write down the value of 2 to the power of negative 3. When there's a negative in the power, that means we need to do the reciprocal, and the reciprocal just means to flip it over. So at the moment, 2 is not written as a fraction, but it could be written as 2 over 1. So the reciprocal of that would make it 1 over 2. So the 2 is going to become 1 over 2. But we also have that 3 in the power. And that 3 there is just a normal power. So that is going to become a power of 3 on the top and a power of 3 on the bottom. That's nice and easy to work out because 1 to the power of anything is always just going to stay as 1. We just need to work out what 2 cubed is. So to get that, we'd just do 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. So our final answer for that question is 1 over 8. And there we go, there is some negative indices. For our next question, James rounds a number x to 1 decimal place. The result is 7.2. Write down the error interval for x. So for this one here, we are thinking about where 7.2 lies on a number line. So 7.2 would be here, 7.1 would be here, and 7.3 on the other side. And when we're looking at error intervals, we're thinking about where's that cutoff point in between those that would still round to 7.2. So in between 7.1 and 7.2, you have 7.15, and it can help to add some zeros onto these numbers because then you've got 7.10 and 7.20, and 7.15 just seems a little bit more visually easy to see. In between 7.20 and 7.30, you've got 7.25, and that's called your lower and upper bound. Now it's important to note that the upper bound there would round to 7.30, and if you look at your error interval, what's on the dotted line, you can see here that there's not an equal to symbol on that inequality. And that's because that is the upper limit. It couldn't actually be that, it has to just be under that. And that's what that means on the symbol there. So we have 7.15 and 7.25, and that is our error interval. And as a fail-safe method for these questions, always just stick a 5 on the end of the number and stick it in that position there, and you're definitely going to bag yourself 1 mark. So there we go, there is an error interval. For question 5, we have here are the first 6 terms of a Fibonacci sequence. So a Fibonacci sequence is when the first 2 terms are added together to get the next one, and then the second and third term are added together to get the fourth. So if we have a look, it does say this. It says the next term in the sequence is the sum of the 2 previous terms. Find the 9th term of the sequence. Well, we already have 1, 2, 3, 4, 5, 6. So we need to find 7, 8 and 9. So to find term number 7, we have to do 8 plus 5. 8 plus 5 is 13. Then we've got to do 8 plus 13, and that's going to give us 21. And then 21 plus 13 gives us 34. And there we go, that is our 9th term in the sequence. For the next bit, it says the first 3 terms of a different Fibonacci sequence are A, B and A plus B. Show that the 6th term is 3A plus 5B. The important part here is it says show that. So if we're going to show that, we need to make sure that we do show what the 4th, 5th and then the 6th term is. So for the 4th term, we are going to do the B plus the A plus B. You could write that down. You could write down A plus B plus the B. I've joined those up so the B's are right next to each other. And that is A plus 2B. And that would be your 4th term. You could write this down. Then I need to find the 5th. And then I'm going to find the 6th. And that'll be my answer. So the 5th is going to be the 3rd term there plus the 4th that we've just worked out. So you have A plus B plus the A plus 2B. You don't necessarily need to write down the full calculation here. We've shown enough just by doing that 4th one. So we've got 2 A's in those 2 terms. So we have 2A. You've got a 2B and a 1B. So that would be plus 3B. And then for the 6th term, and let's just start to highlight this a little bit because we don't want to get lost here. We have a 2A and a 1A. So that's going to give us 3A. And then we also have the 2B and the 3B. And added together, that gives us 5B. And there we go. We have shown therefore the 6th term is 3A plus 5B. Okay, on to the last part. It says, given that the 3rd term is 7 and the 6th term is 29, find the value of A and the value of B. Well, the 3rd term up here was A plus B. So that there tells us that A plus B is equal to 7. It also tells us that the 6th term is 29. And the 6th term we've just worked out, 3A plus 5B. So 3A plus 5B is equal to 29. So we actually have a pretty difficult question here. We've got a simultaneous equation. Now, of course, as due to the nature of what we're actually covering here on this particular video, we are covering the topics that were not covered in the previous ones. So this isn't in order of difficulty, but a question like this with simultaneous equations on a foundation paper would definitely be towards the end of the paper. So don't be thrown off by the fact that we've got some pretty tricky questions appearing very early on. So just here then, when we have a simultaneous equation, we need to make the coefficients of A or B the same. I tend to always focus on the coefficients of B. So to make, or the second piece there, in this case it's a B. So to make them the same, I'm going to have to multiply the top equation by 5. That's going to make me have a 5b. So I'll just write that down below. So I now have 5a plus 5b, and that is now equal to 35. And once the coefficients are the same, as long as those symbols are the same, all you do is take the equations away from each other. So 5a take away 3a rather than doing 3a take away 5a because I don't really want to deal with negatives. 5 take away 3 is 2a. 5b take away 5b has disappeared. And 35 take away 29 is 6. So if 2a's are 6, 1a must be 3. And that gives us a equals 3. And then you have one more step to find the value of b. And you can sub it into the easiest equation out of the 3 that you've got there. The easy one is probably this one. So we're going to sub a equals 3 into, and if we labelled these equations with numbers 1 and 2, I'm going to sub it into equation 1. So that would be 3 plus b is equal to 7. So therefore, taking away the 3's, b would have to be equal to 4. And there we go, we get b is equal to 4. So there we go, some simultaneous equations there. I know it's very early on. Simultaneous equations is one of those grade 5 crossover topics as well. So there we go, don't be put off by the fact that it's only question 5. As I said, we are just covering all those topics that we needed to from those previous papers. So question 6, here is a star shape. It says the star shape is made from a regular hexagon and 6 congruent equilateral triangles. So that congruent word means that they are exactly the same. It says the area of the star shape is 96. Work out the area of the regular hexagon. So the regular hexagon is this shape right here on the inside of the star. Now looking at the shape that we actually have there, because of the way it's drawn on this particular grid, if we were to split this hexagon up, a hexagon is actually made out of 6 equilateral triangles. So we actually have just a load of congruent equilateral triangles here. And we just need to count how many we've got. We've got 1 on the top row, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So within that shape we have 12 congruent equilateral triangles, and the total area is 96 centimetres squared. So to work out the area of each one of those triangles, we could do 96 divided by 12. 96 divided by 12, we could take some time to work that out. If it was a calculator question, that'd be easy enough, but otherwise we would just need to work that out. So 8 times 12 is 80 plus 60 is 96, so it is 8. There we go, you can normally have a pretty good guess at these. Just double check, obviously don't guess in your exam, but it is 8 times 12. So each triangle has an area of 8. So where it says work out the area of the regular hexagon, well, let's just have a look at how many triangles are in the hexagon, and it does obviously link to the amount of sides it has. You can see that there are going to be 6 of those triangles. There you go, 3 on the top, 3 on the kind of bottom there. So if each one has an area of 8, we'd do 6 multiplied by 8, and that gives us the area, which is 48 centimetres squared. Another way that you could think of this, to be fair, looking at it, you've got 6 triangles in the centre of the hexagon, and you have 6 triangles around the outside. So therefore the area of the hexagon must be half of the area of the total shape. So to be fair, we could have just done 96 divided by 2. Although, there we go, it was only 2 marks. It doesn't really matter which method you use there. That was maybe a slightly more advanced way of thinking. I guess it just depends on how you look at it to start with. But there we go, 2 different methods that you could use for a question like that. Okay, on to question 7. So we have a dual bar chart. So in this bar chart here, we have, and you can see straight away from the key, boys are the grey bars and girls are the ones with the sort of diagonal lines in. A teacher asked the students in year 6 what type of transport they use to get to school, and the dual bar chart shows some of the results. What is the most popular type of transport used by the boys? So we're looking for the highest bar in grey, and that is this one here, which is walk. So we would just write down the word that's at the bottom of the bar chart. There we go, walk. 7 girls walk to school. Show this information on the dual bar chart. You've got to watch out for questions like this because sometimes they're kind of hidden away. There's no dotted line and you can easily miss them. So make sure you read all the questions carefully. So 7 girls walk to school. So we want a bar joining on up to the 7, which we can see just here. Making sure you do this nice and neat with the ruler. And then apply any shading that you've been asked to in the key. So this one has the diagonal lines. So there we go. We don't want to spend too long putting these lines in, but there we go. There we are. Happy with that. More of the students go to school by car than by bus. How many more? Well, we need to know how many go by car, how many go by bus, and then we can say. So we've got car and bus just here. For car, you can see you've got 5 and 9, and 5 and 9 makes a total of 14. And for the bus, you can see that we have 6 and we have 4, and that gives us a total of 10. So if we're going to write down some working out for this at least, we would just write down 14 take away 10. So if we write that down, 14 minus 10, and that gives us a total of 4. The number of students in year 5 is the same as the number of students in year 6. Work out the total number of students in years 5 and 6, or what is the total number in 5 and 6? Well, this whole bar chart is about the students in year 6. So if we know the total in year 6, we'll also know the total in year 5, as it said that they're the same. Now we've got the total amount of students for car and bus, we just need to get walk, cycle and other, and then we'll just be able to double that. So for walk, you've got 9 for the boys and 7 for the girls, so 9 and 7 gives us 16. For cycle, we have 4 for the boys and 1 for the girls, that's a total of 5. And on other, you have 2 for the boys, 1 for the girls, that's a total of 3. So we need to add those all together. So we've got 14, 24, 45, 48. There we go. So it's 48 there. So in year 6, let's just write year 6, there are 48. So that means in year 5, there will also be 48. That's not 48. Let's write that properly. 48. And all we need to do is add those together. So that'd be 96. Again, you can just do your column addition there, but that comes up to 96. And there we go. There is some using or interpreting a dual bar chart. Okay, question 8. Find an equation for this line L. So when you're writing the equation of a line, you just need to know that the equation of a line is written in the form y equals mx plus c. From there, you need to know that m is the gradient and c is the y-intercept. There we go. So the y-intercept is a really easy one to get a mark on this particular question. It's 3 marks, and here is the y-intercept sitting down at -6. So even if we write y equals mx, or any number in there, minus 6, we're definitely going to get a mark because that's our y-intercept. The bit that requires a little bit more work, although not much, is just to figure out what the gradient is. So to find the gradient, just go from that y-intercept across by 1 square, make sure you only go across 1, and then have a look at how far up or down it is to get to the line. So to get to the line, I'd have to go up to there, and that would be a jump of 1, 2, 3. So that is up by 3. If it was going down, we would put -3. Now, the gradient is just how far up or down you have to go to get to the line when you go across by 1. So in this case, we have to go up by 3. So this number here is going to be 3. So our final answer would just be y is equal to 3x minus 6. There you go, really nice and easy to find. Sometimes it might go up by a fraction, and normally they're not the most horrible ones. If they do, it might be that it goes up by a half or 1.5. That's absolutely fine as well. So there we go, on to our next question. Okay, so for this one, we are going to be drawing a pie chart. So what we are going to do is flip over to another app so that we can actually get the protractor out and have a go at this one. So before we get the protractor out and draw it, let's actually find the size of the angles, then we can just do the other part nice and quick. So when it comes to a pie chart, all the information has to add up to 360. We know that because it's a circle, and around this point here, you have got 360 degrees, and we need to make sure we fill the pie chart. So at the moment, have a look at what the question's about. So it's about the snacks that people preferred and the amount of fans that voted for them. So we just need to figure out how many fans voted. So 11 plus 17 is 28, plus the 8 is 36. Now that's a really nice total because we want it to equal 360, and it's really obvious to see what you multiply there to get to 360. If it was slightly more complicated though, you'd just do 360 divided by that total, which in this case is 36, and it gives us the number there, which is 10. So in order to get all the angles, we need to multiply all of these by 10. So 11 times 10 is 110, 17 times 10 is 170, and 8 times 10 is 80. And they're the angles we're going to use on our pie chart. Once we do that as well, we are just going to label those angles with the appropriate snack. So let's go ahead and actually draw that. Okay, so on to plotting them onto the pie chart. You want to put your protractor so that that crosshair in the middle is directly on the centre of the pie chart. And we want the 0 on the outside, so I tend to measure going clockwise. We don't have to have it on the outside, we can use the inside numbers, but for ease of plotting I tend to put them on the outside. You want that 0 pointing directly at the centre, so I'm happy with that placement. Then we're going to measure out that 110 degree angle. Now you can see on the outside, 110 degrees is just there. So we can mark that, and it might go onto the outside of the pie chart, it might go on the inside, depending on how big the protractor is. And then you get your ruler and a pencil and you join up from the centre as best as you can through that mark to the end of the pie chart. Once you've done that, you want to label it. So the first one that we had was burger, and that was 110 degrees. Now the next part is where you need to be really careful. So we're going to put that back onto the centre, but we're going to rotate our protractor so that 0 is now pointing down our new line. And again, we want to get that as accurate as possible. From there, we can now measure out the next angle, and the next angle was pi, and it was 170 degrees. So 170 is almost right at the end of the protractor, it's over here. And there we go, we can move our protractor out the way. And we can again get our ruler joining from the centre to the outside of the pie chart, and then again labelling what that part is. So that was pi, actually use a proper pencil there, so that was pi, and that was 170 degrees. Now our last one was hot dog, I'm just going to write HD, and that was 80 degrees. So we can put that into the pie chart, although at this point, as good practice, we should make sure that we still measure that angle just to make sure that it is actually coming out as 80 degrees. So rotate it around to 0 as accurately as you can. And there you go, happy with that. That is on 80, it's pointing right up to the top there, straight up the line. So that is a perfect angle measured out. And there you go, that is your pie chart drawn. Okay, so on to our next question. So here's the graph of y equals x squared minus 2x minus 3, and the graph's been drawn for us. It says write down the coordinates of the turning point on the graph, and we've got the same equation there. So it's just this graph in the actual diagram. So the turning point is the point on the graph where it stops going down and starts going up, or of course if it was a negative quadratic the other way, stops going up and starts going down. But this one here, it goes down and then slopes up. So the turning point is this particular one here. So we just actually need to read that coordinate. So the x coordinate is 1 and the y coordinate is negative 4. And we can see that just over here. So there we go, that coordinate is 1 and negative 4. For part B, it says use the graph to find the roots of the equation where it equals 0. And where the graph equals 0 is just ground level. It's where the x coordinate there meets the x-axis. So where y equals 0, we're looking for the x coordinate where the graph meets the axes. So we have two that we need to have a look at on a quadratic. We've got this one here, and that goes perfectly through negative 1, and this one here, which goes perfectly through 3. If they were decimals, we would obviously read them really accurately, but they've come out as nice whole numbers, so we would just say negative 1 and 3. And there we go, there are our solutions, or the roots of the equation. So there we go, on to the next one. So we've got some different graphs to look at. It says here are 6 graphs. We have a quadratic, a cubic, we've got a reciprocal, and E there we have a straight line graph as well. So we need to identify, let's have a look, write down the letter of the graphs that could have y equals x cubed and y equals 1 over x. Now these are just some graphs that we should be recognising. So in terms of a cubic, we have B and we have F. And that's what we're looking for here. We are looking for a cubic graph. Now in terms of actually recognising these, the graph of x cubed only has one intercept with the x-axis, and that's that one there where it meets the origin. This cubic graph here would be a little bit more complex, so it might be something like x cubed plus 2x minus 3x or something along those lines, plus 2x squared. It'd have something else along with the x cubed. So it's not b, it's going to be f. So that is our graph f. For part B, we are looking at a reciprocal graph. And if you have a look, we have two there that are reciprocal graphs. You've got C and you've got D. Now C, this reciprocal graph, goes into the negative part, and D is in the positive part, or the positive quadrant. Now if we look at that reciprocal equation there, it's positive 1 over x. So we're looking at a positive reciprocal graph. And our positive reciprocal graph is that one there, D, that's in the positive quadrant. So that is D. So there we go, there are our equations. If we had one that said y equals x squared, that would be A. As you can see, that looks like the question we've just looked at. And if we had one that was y equals x, and it would have to have a positive y-intercept there, so I don't know, something like +4, that would be graph E. So there we go, that is all just about recognising the types of graphs that we're asked to draw and thinking about then identifying them, but use process of elimination on these. If you recognise that A was a quadratic and E was a straight line graph, you could cross those off straight away and narrow down some of the ideas. So there we go, that was identifying graphs. Okay, so this question is asking us to work out an estimate for the mean time. It says to give our answer correct to 3 significant figures. So although the previous questions could have been on a non-calculator paper or a calculator paper, this particular one is definitely a calculator question. Obviously the nature of the questions that we're doing here, we are just filling in the gaps from the previous 3 papers, so it is a bit of a mixture of calculator and non-calculator. But as I said, this one's definitely a calculator question. So to work out the estimate of the mean from a table, we need to actually use the midpoints. We want to find out the total of each row, and in order to do that, we need to basically use a mathematical guess, which is a midpoint of the particular class intervals that we have in each row. So between 5 and 10, the midpoint of that is 7.5, and if you're not sure how to find the midpoint, you can add together 5 and 10, divide it by 2. But that midpoint is 7.5. In between 10 and 15, you can use the same process, but the midpoint is 12.5, then we have 17.5 and 22.5. Now what we're going to do, we've got one of those 7.5s, so we can times those, and that is just 7.5. We have 2 lots of 12.5, which is 25. We have 7 17.5s, I'm definitely going to type that one into the calculator, so 2 times 17, 7 times 17.5, and that's 122.5. There we go, and 22.5 times 8, and that is 180. Now all we need to do, add those all together. Let's type them into the calculator, make sure we don't make a mistake. So 122.5 plus 25 plus 7.5, and that gives us an overall total of 335. And again, that's just an estimated total as we are using the midpoints. Now to work out the mean, you add them all together, get our total, which we've got 335, and divide by how many people or how many numbers we have. Now in terms of how many numbers we have, we'd find that here by the total frequency, but it does tell us in the question that there are 18 students. So that must add up to 18. So in terms of finding out the mean here, we just do 335 and divide that by the 18 numbers in the table. So just type that in your calculator. And we get a recurring decimal there. It comes out as 18.61 recurring, which just means there's loads of ones. So in terms of writing this to 3 significant figures, well, the third significant figure is the 6, and after the 6, it's just recurring ones. So our answer would just be 18.6, and that would be our final answer, 18.6 seconds as our estimated mean. Okay, so moving on to our next question. A new phone costs £679. The value of the phone decreases at a rate of 4% per year. Work out the value of the phone at the end of 3 years. Now this particular question here is depreciation. Now, depreciation can be calculator or non-calculator, although something like 4% is going to be a calculator question. So we're going to use a calculator method for this. So a new phone costs £679. So in year one, because it's at the end of 3 years, it's going to lose 4%. It's going to have a new value, it's going to lose 4% again. So if we were to use a non-calculator method, we'd have to work out 4%, take it off, and then work out 4% of the new amount, take it off and do it again. But for an actual calculator method, we're going to think about what percentage is left after 4% is gone. So if we do 100%, take away 4%, that leaves us with 96%. Now, to actually work out 96% of an amount, there's lots of different ways you could do that. You could divide by 100 and times by 96, or you can use a multiplier for 0.96. So 96% is 0.96. Now you can use that straight away. You can just do £679 and multiply it by 0.96 and it will take 4% off for you. You can do that 3 times and get your answer, or you can save yourself even more time and you can put a power of 3 with the multiplier. So I can just type that in one go. £679 times 0.96, put a power of 3, and it gives me an answer. It comes out as £600 and 0.735. So we could either say 73p or mathematically round it to 74p. Either answer would be fine there. Both would be accepted, and that would be my final answer. Now, the only issue with this particular method is that if you don't know it very well and you make a mistake, it's very difficult to pick up some of those. Well, this one was 3 marks. So when you are doing this question, if you don't know this method here with absolute certainty, using a multiplier, then what I would do is work out 4%, so divide by 100 times by 4, take it off, and just keep doing it. It's going to take you about 5 times the amount of time, but you're definitely going to get method marks. So it's a fail-safe method in the exam. But there we go, that is a nice quick method, and it is worth knowing the use of a multiplier, because again, it's going to save you a lot of time in the exam. And there is my answer, £600 and 74 pence. And on to our next question. Okay, so we have a distance time graph. Now it says on here that Ella cycles to her friend's house. She stays at her friend's house for a number of minutes and then she cycles home. Here is the travel graph. For how many minutes did Ella stay at her friend's house? So you just need to make sure you read this very carefully. So the point at which she stayed at a friend's house is where the line is flat, this part just here, as she's not travelled any distance. So if we go down and see the time, she got there at 8:30 and she left and started travelling home in between 8:40 and 8:50, so that would be 8:45. So from 8:30 to 8:45, hopefully that's quite a nice one there. You can see that that is going to be 15 minutes. It does ask for that in minutes, that's fine for us to just say 15. So just check the line there, just make sure you know what units is wanting it in. For part B, how far is Ella from her home at 8:50? So at 8:50, there we go, this is a bit of an awkward part on the graph, we've got 8:50 just over here. So if we go up from 8:50 and then use a ruler and a pencil to really carefully trace along that exact line, there we go, and that is just in there. Now you can see that that is 3 little squares up from 4, and if we count up each little square just to make sure we get this correct, that it would be going up in 0.2s. So that there would be 4.2, then 4.4, 4.6, 4.8, and then we hit 5. So this particular one is landing on 4.6, so our final answer there would be 4.6. There we go, and the units is kilometres, so 4.6 kilometres. And there we go. Always be very, very careful with the scale. Part C, work out Ella's speed in kilometres per hour for the first 20 minutes of her journey. Well, let's have a look. So the first 20 minutes goes from 8 to 8:20, takes us to this point just here. Let's do this in another colour. So in terms of that, she's gone 20 minutes in time, and in terms of distance, she has gone 4 kilometres. So 4 kilometres in 20 minutes. Let's just write that down here. 4 kilometres is equal to 20 minutes. Now in terms of working out a speed here, again we could think about a calculator and a non-calculator method, and I really like the non-calculator method for this. Now in terms of working out a speed, we normally give a speed in kilometres per hour, and that is what it's asked for on the dotted line here. So if we want an hour, we don't want 20 minutes on the right hand side there, we want 60 minutes because that's an hour. To get there, you would multiply by 3. So in terms of the distance, you could also multiply that by 3, and that would be 12 kilometres. We know that if she does 4 kilometres in 20 minutes, she's going to do, at that speed, 12 kilometres in 60 minutes. Now, if we do 12 kilometres in 60 minutes, or 12 kilometres in an hour, then that is an answer of 12 kilometres an hour. So there we go, a really nice method. If you were unsure, though, and you knew your speed, distance, time formula, which we can put into a formula triangle, you can write speed, distance, time. And of course, if you had a calculator here to work out speed, you'd do the distance divided by the time, which would be 4 divided by the time, although we'd want it in hours. So you would have to convert the 20 minutes to hours, which is 20 over 60, or 1/3, and you'd do 4 divided by 1/3, and that does come out as 12. So there are different ways that you can do it with a calculator, although I actually think here the non-calculator method is easier than the calculator method. So something to look out for there. I would suggest that this would be a really good question to come up on a non-calculator paper. So question 15. So on the grid below, draw the graph of y equals 1 minus 4x for the values of x from -3 to 3. Now straight away, the first thing that stands out to me is there's a huge gap there for something. Now normally on one of these questions you'll probably recognise you'd be given a table. So we're going to use this space to actually create a table. It gives us the x values, so for x we've got -3 along to 3. So -2, -1, 0, 1, 2 and 3. We want to know the y values, or the y coordinates. And it tells us here that y is equal to 1 take away 4 lots of x. Now I would always start with the 0 in the middle. I always think this is the nicest one to start with. I'm just going to highlight this particular area. And then we can work upwards and try and spot a pattern. So 1 take away 4 lots of 0, that's 1 take away 0, is just 1. So a really nice, easy one to get. And there is our mark. And we know as well from an earlier question that number in the question, not the one next to the x, but the number, is the y-intercept. So it would make sense that that would be 0 and 1. For the next one, you have 1. I'm going to write the working out down for this particular one. You've got 1 take away, and then you've got 4 times 1, as our x value is 1. We know through order of operations we need to do the multiplication first. So it's 1 take away 4, which is -3. So that's going to be -3. We'd then do the same process, and we would just change the 1 for a 2. So I can change the 1 there, get rid of this, we'll get a different answer for this one. So 1 take away 4 times 2, which is 1 take away 8, which is -7. So you can see here the process that I'm going through, and you can probably spot now as well that the graph is going down in 4s as we move to the right. It's gone from 1 to -3, then down to -7, so the next one is going to be -11. And you can see as well there is a hint here in the -4 there, which is next to the x, which does actually tell us the pattern that it goes in from left to right. If we want to go the opposite direction, we would have to be going up in 4s. So when we start going this way, we're going to +4, and when we were going this way, we're going to be taking away 4. So add 4 to the 1 would give us 5, then we'd get 9, and then we would get 13. And of course, you can always check one of those after you've drawn the pattern in, just to make sure that you're definitely correct. You don't want to make a mistake there. But the good thing about drawing a straight line graph, which is what this is, we'll know if we've made a mistake because it won't make a straight line. We'll talk about that as we draw it. So 0, 1 was there. 1, -3 is down here. And again, being very careful of the scale, because as you can see, look, on the x-axis, it's 2 squares across for every 1. And on the y-axis, it's only 1 square for every 1, but it's been labelled in 2s. So be very, very careful there. But as you start to draw it, you will also spot a pattern in the points. So 2, -7 is here. And I can already see now that for every point, look, I go across 2, down 4. So I can keep following that pattern. If I go across 2 from that latest point, down by 4, it ends up just here. And that matches the negative 13 that we have in the table. Negative 11, sorry. For the next one, minus 1 and 5, I can see the numbers now, so a little bit easier to actually find these points. And we have negative 2 and 9, which is just here, and negative 3 and 13, and that's where the 13 was I was thinking about. And as you can see now, that does actually make a nice straight line. So don't forget, you need to get your ruler and your pencil, you need to join them up, making a nice straight line. I'm doing this freehand, so I'm trying my best, but you would obviously use a ruler and a pencil and make sure you don't miss off any of those points. Now, what is quite common is that the negative numbers tend to go wrong. So you might see something in yours where you get this sort of pattern going on, and then all of a sudden your line sort of comes down. Now that is a huge indicator to you that you've made a mistake. And if you can't figure it out in the numbers for whatever reason, because you're in the middle of an exam and you don't really know why your graph's gone wrong, what I would suggest is just trying to look for the pattern. So here, what I did for that final point on the right, I looked at 2 squares right, 4 squares down, and I just spotted the pattern. And failing that, you could just get your ruler, join up a nice straight line, and kind of make sure you get those points in the right place. But there you go, there is drawing a straight line graph. Okay, so we've got some sampling. Carla is planning a day trip for 195 students. She asks a sample of 30 students where they want to go, and each student chooses one place, and we can see that in the table. Work out how many of these 195 students you think will want to go to the theme park. Well, the theme park is just here, and there are 10 students in the sample that want to go to the theme park. We already know from the question the sample was 30 students. So in terms of looking at this as a proportion of the 195, this particular option here, 10 out of 30 students said that they wanted to go to the theme park. Now we need to work out that as a fraction of 195. So it can help to simplify this fraction if it can. Before we do that, they both divide by 10, so that's 1/3. So if this sample represents the rest of the students, then we would assume that 1/3 want to go to the theme park. So we just need to find 1/3 of 195. So I can write that down, 1/3 of 195. That's easy enough for me to do. I don't need a calculator for that. I could just divide by 3, of course, if it's on a calculator paper. Don't waste your time doing bus stop division, but just highlighting the fact that this doesn't have to be a calculator question. 3 doesn't go into 1. It goes into 19 up to 18, so 6 times, remainder 1, and 3 goes into 15, 5 times. So there we go. We would assume as long as that sample represents the rest of the people, that 65 people would want to go. For part B, it actually mentions something here that I've already talked about. It says state any assumption you made and explain how it may affect your answer. So we assume the sample represents the rest of the students. There we go, represents the rest of the students. Now, if the sample does not represent the rest of the students, then our answer could be wrong. It could be higher or it could be lower. So in terms of that, we would need to give this, because it does say explain how it may affect your answer. Otherwise, the answer would be wrong. Okay, or the answer could be higher or lower. There we go. Higher or lower, which is basically just saying it would be wrong. So there we go, there is our assumption, and we have explained how it might affect our answer if our assumption is wrong. On to question 17. So write down the modal class interval from this table. Now the modal is just the word for mode. There we go, when we are looking at these class intervals. The mode is the most common. So if you look at your table, you can see that the most common thing to appear occurred 10 times. And that represents this particular class interval. So in terms of the heights, it's asking what's the most common height, or the most common height interval. And the interval that's the most common is 160 to 70, 160 to 170. There we go, and that's our modal class interval. For part B here, there's been a frequency polygon that's been drawn incorrectly. It says right there, this incorrect frequency polygon has been drawn. Write down 2 things that are wrong with it. Now straight away, the thing that I can see immediately that's wrong is this particular line here. When you draw a frequency polygon, there's only a couple of rules. You plot on the midpoint and against the frequency. So it's very difficult to actually draw it incorrectly, but this is quite a common one here where people join it up. And you can imagine why, because the word says polygon. We know that a polygon is a shape, and a shape doesn't normally have a gap. But in terms of a frequency polygon, it does. This particular line is not drawn, which is a very annoying piece of language there, but that should not be there. Okay, so in terms of write down 2 things that are wrong, the first and last points are joined up. Are joined, and if you're not sure exactly how to describe that, you can always point an arrow from your reason to the diagram to show the bit that you're actually talking about. Now we need to find the second thing that can go wrong. So if the person drew the axes themselves, they could go wrong. So it's worth checking that. Along the bottom, 120, 30, 40, 50, 60, 70, 80, 90, that goes up in tens, that's fine. And on the left, it goes 0, 2, 4, 6, 8, 10, 12. So that's absolutely fine as well. So it must be the points that are plotted incorrectly. So looking at the table here, it has to be plotted on the midpoints. So we're looking in the middle here, which we've done before. We won't necessarily write them down. Let's just have a look. So that top one should be 135, but it's been plotted on 130. There we go. So straight away, you can see it's not been plotted on the midpoints. There we go. So in terms of describing that, we would just say the points have not been plotted on the midpoints. Have not been plotted on midpoints. You could say the midpoints of the class intervals as well. You could make it as fancy in terms of your language as you want. And then, you know what, sometimes there's even 3 mistakes. So you could check for another one, but we found 2. Let's have a look. 1, 7, and then 8, 10, 4, 8, 10, 4. So the points are all plotted at the correct heights. So yeah, they were the only 2 mistakes there for that particular frequency polygon. Okay, question 18, we've got some reverse mean. It says here 4 red bricks have a mean of 8, 5 blue bricks have a mean of 9, 1 green brick has a weight of 6. Donna says the mean weight of the 10 bricks is less than 7. Is Donna correct? And you must show how you get your answer. Now when it comes to a reverse mean, we are just doing exactly what the topic says. It's the reverse. So when you normally find the mean, you get the total. Let's just imagine we have a total. You divide by how many there are. Let's have a look at this first statement here and think about how that would apply to this. We'd divide by 4 because there are 4 red bricks, and you would get a mean, and it tells us here that that mean is 5. But what we don't know is this total on the top. So to get that total, you can write it out as an equation like this if you like, or you can just remember it, you do the opposite. So instead of dividing, we're going to be multiplying. And to solve this equation here, look, you'd times both sides by 4, and we would get x equals 20. But you don't necessarily have to write it as an equation. You can just look at each statement and multiply the amount by the mean. So 4 times 5 is 20. And we can apply that to each row. So here, 5 bricks with a mean of 9. 5 times 9 gives you a total weight of 45. And for the last one, which is a little bit strange because there's only 1 green brick, but I'm going to stick with my process, 1 times 6 gives us a weight of 6. So in terms of the total weight of all of these different coloured bricks, we have 20 plus 45 plus 6. And if you add them together, they add up to a total weight of 71 kilograms. We know that there are 10 bricks because it says it just there, but you can count the 4, 5 and the 1. So to work out the mean of these 10 bricks, we get the total weight, which is 71, divide it by 10. And 71 divided by 10 is just 7.1 kilograms. Now, Donna has said that the weight of the 10 bricks is less than 7. And we've just worked out the mean is 7.1. So actually, no, the mean is greater than 7. Is Donna correct? You must show how you get your answer. I don't need to write too much. I just need to say no, she is not correct. And look, I've just pointed an arrow to the bit of working that shows why she's not correct. So I'm saving myself the hassle of having to write a full statement there that says, no, Donna is not correct because the mean of the 10 bricks is 7.1 kilos. We've already shown the working out, so let's make sure we make use of it. So there we go, there is some reverse mean. Question 19, we have some SOHCAHTOA. So PQR is a right angled triangle. Work out the size of the angle marked X and give your answer to 1 decimal place. So when we are using SOHCAHTOA, first step is to label the two sides in the question. So this one here is the opposite, and the hypotenuse is the longest side. So we have O and H. From here, I would write down my SOHCAHTOA formulas. Okay, you may or may not use triangles, but I will write triangles here because I know that they are a popular method, and a really nice easy way to do your rearranging. So we are going to be using the sine triangle as we have O and H in this particular one. When you are looking for the angle, we cover up the sin, the cos or the tan, so we're going to cover up the sin, and it is O divided by H. Now if you type in O divided by H, and this is a calculator question by the way as well, 5/14 would give you just a decimal. Now, in order to find out the angle that that particular relationship responds to or corresponds to, you have to press Shift and then sin, cos or tan first. For this one we're using sin, so we're going to press Shift sign, and you get on your calculator sine -1, which is just the inverse, which is just when we're looking for an angle. Let's type that in, so Shift, sin, and then press my fraction button, 5 on the top, 14 on the bottom, close my bracket and press equals. And I get the angle here, 20.9248, and there's some more decimals. I'm not going to keep going though, because it does say it only wants it to 1 decimal place. So the first decimal is the 9. After that is a 2, so that's a nice one. That is not going to affect my number, so 20.9 degrees. And there's the size of the angle to 1 decimal place. On to our next question. Show that these two triangles are mathematically similar. Now, when shapes are mathematically similar, it means that they share a scale factor. So they are the same shape, but one is bigger or smaller than the other. But that means that all sides must follow that same scale factor. So if we look at this particular triangle here, we want to pair up some of the similar sides. So we have 12.5 and the 5. They are both the hypotenuse of this triangle. So to find out what the scale factor is between those two sides, I would do 12.5 divided by 5, and that's going to tell me what we've had to multiply by. It's a calculator question as well. 12.5 divided by 5 is 2.5. So there we go, 2.5 is our scale factor. Now, the fact that it says show that they're similar means that they are definitely similar. So we just need to make sure that when we get the smaller sides and multiply them by 2.5, we get the same as the bigger sides, or of course the other way around. If I take the bigger sides and divide them by 2.5, I get those smaller sides. It doesn't really matter which way, I could do one of each. So let's go from 10 to 4, which is the other base of that triangle, I guess. If you were kind of to rotate that one round, you could kind of redraw this triangle so it looks in the same orientation. You've got the 5 as the hypotenuse, the 3 would be here, and the 4 would be here. Might help just to redraw that. I do like redrawing the shapes when you're looking at similar shapes so that they're in the same orientation. So if we're going from 10 to 4, that is dividing by 2.5. Again, we are showing it, so we should probably show that working out. So 10 divided by 2.5, check that, but that is 4 centimeters. So that's correct. And then for the other one, let's just so we can try both methods, let's go from 3 to here. There we go, and going from the small to the big, you would multiply by 2.5. Let's write that down, so 3 multiplied by 2.5, that does equal 7.5. So there we go, that is a correct length as well if they are mathematically similar. All of those lengths have the same scale factor. Again, or you could have shown this a slightly different way. You could have just done the big side divided by the little side for all 3 and shown that they all came out as 2.5. Absolutely fine, whichever way you kind of want to show that, but we are looking at all 3 sides there just to make sure one of them wasn't incorrect. Okay, there we go. So there were some similar shapes. On to question 21. Straight away, as soon as I see this question, I know that I can either draw a two-way table or a frequency tree to start organising all of this information, because I can already see that final line says how many females run. And if you try and do this without a two-way table or a frequency tree, I don't know about you, but I tend to get lost by the third or fourth line. So I'm going to draw a two-way table, have a look at the information in the question so we know how big it needs to be. It says 100 adults were asked how they keep fit. Each adult goes to the gym, runs or cycles. Okay, so I need to have gym, run, cycle, and a space for the total. So I put gym, run, cycle, total. You can write the full words in if you like, but these are just to help us. It says then they are male or female, so we need to split this up. So male, female, and again a total. And then we'll just fill in the information we got from the question. So the first line, 100 adults were asked, 45 of them were female, so 45 here. 30 of the 52 adults who go to the gym are female, so that tells us that in the gym column there, 30 of the 52 adults are female, so 30 females out of the 52 adults. Tick that off. 35 adults run, that's the total for running, and then 9 males cycle, so 9 just there. So that's all the information from the question. It wants to know how many females run, so it's wanting us to work out this box just here, and we just need to figure out how to get there. So I just fill in anything that we can see. I'm going to go down the columns to start with. So in the first column we have a missing box that has to add up to 52, so that must be 22. Second column we don't have anything, third column we don't, and the fourth column we have the total there that has to add up to 100, so that'd be 55. And now I'll go along the rows. So on the top row we have one missing box, the 22 and the 9 combined add up to 31, and it has to get to 55, so that must be 24. And then the next row we've got 2 missing, so we can't do that, but we can do the bottom one, 52, 35, and our missing one there would be 13 to make it to 100. Yeah, 52, 35 and 13. And then our missing box just above that must be 4. There we go, and actually we have 11 here if we want it as well. So the answer for this one, let's have a look. Run. I've just realised I've actually put the box there in the wrong one. Now I did know which one I was looking for, but for some reason I've put it there. So we were actually looking for this one. There we go, and that is probably a good reason why you should put the full words in. There we go, so you don't do something silly like that. So there we go, there is our answer. It is 11, it is the amount of females that run, and there we go. So 11 would be our final answer. And there we go, that's using a two-way table. Of course you could draw a frequency tree, but when it's 3 things, unless I'm forced to fill in a frequency tree, I do tend to avoid them. I just prefer a two-way table. I just feel like they're a little bit more organised. But there we go, you do need to know frequency trees as well, so you could always practice that with a frequency tree. Okay, on to plans and elevations. So question 22, we have to draw a plan. A plan is the view from above. Again, you could only really be asked the plan for this particular diagram because it doesn't tell us where the front or the side are. Okay, so normally it might have some arrows that might say something like this. It might say this is the front and this is the side. And when they do that, it's normally because they want you to actually draw a front or a side. But a plan is from above. So we need to have a look. So if we were looking from above, we would see, and I'm just going to do each row at a time, we'd have these 3. And that would be something like, let's think, make sure we fit this in. You know, we'd see this bit here. Okay, draw part of it. Then we've got the 2 here. That's only above those ones, so kind of continue that round. And then you've also got this one on its own, right on the right-hand side. So there we go. That would be the plan that you'd see. Now, to be fair, you could add in as well a sort of line here where the height actually changes. So sometimes I do recommend always drawing that little line in there where there is a change of height or a change of depth. But to be fair, I think this one would probably be okay because it's got all those lines on it there. You'd actually see the lines too. So arguably for this particular one, you might actually argue that To be fair, these should have the extra lines in here as well, because you would actually see them from above, but you don't need to stress about that too much. Good practice is always to put a slightly thicker line where there is a change of height. And there we go, there is our plan. Alright, so for our next question, multiplying decimals, I always get a bit annoyed when it's a multiplying decimals question, because although it's very easy marks, it's just a bit time consuming. But there we go, let's take the decimals out. We've got some column multiplication to do, and we'll put 2 decimals back in at the end. Really nice, quick and easy method. Obviously not a calculator question. So 546 multiplied by 43. We do this very carefully. So 3 times 6 is 18. 3 times 4 is 12, plus the 1 is 13. 3 times 5 is 15, plus the 1 is 16. We're now moving on to the 4, which is 40. So add in our placeholder. 4 times 6 is 24. 4 times 4 is 16, plus the 2 is 18. 4 times 5 is 20, plus the 1 is 21. Of course, there are loads of different methods of multiplication you could use as well. If you want to use grid method or the lattice method as well, you could use that. But add these together. 0 and 8 is 8. 3 and 4 is 7. 8 and 6 is 14. And then 3. And then 2. So 2, 3, 4, 7, 8. We had 2 decimal places we took out at the start. So 1, 2 back in. And our decimal will go just there. So there we go, write that nice and neat on a dotted line, 234.78. And don't forget, on a question like this, you can always estimate the answer, so you know around about where that decimal should go, just in case you get a bit confused in the moment. That estimated would be 50 times 4, which is around about 200, so you know it's our answer's obviously in the correct ballpark. Go on to the next one. Pressure, force and area. So this particular question here, we have a shape drawn for us. It says the prism has a height of 3 meters, which we can see there. The volume of the prism is 18 meter cubed and the pressure on the floor is 75 newtons per meter squared. Work out the force exerted by the prism on the floor. Now we've been asked for force, so straight away this formula, which I would put into a formula triangle, we're going to be using the force. So pressure is bottom left, force is on the top, and area is bottom right. So pressure is equal to force over area. If we want to use the force, then cross off force, and that is P multiplied by A. So if we're going to do pressure multiplied by area, that means all we need to do is find those numbers from the question. So we have pressure here, which is 75. So we know that's going to be 75. We just need to multiply it by the area. But the problem is we're not actually given the area. We're given the volume. So we know that the volume of any prism is the area of the cross section, which is also on the base, but I'm going to draw it on the top here. There we go, as they have the same cross section either side. We would take that number and multiply it by the height, or the distance that it goes through the prism. So if that would give us 18, that means the area, let's call it x, multiplied by the height, which is 3, gives us the volume 18. That's relatively easy for us to solve. We just divide by 3, or do the volume divided by the height, and you get x. The area must have been 6. So the area here must have been 6 meters squared. So in terms of working this out, it's just 75 multiplied by 6. There we go. So relatively easy for us to get the answer there. 75 times 2 is 150, so times 6 is 450. There you go, 75 times 6, obviously you can do your multiplication for that. But that is 450 newtons, and that would be the force exerted by the prism on the floor. And there we go, there is some pressure force area. On to our next question. So for this one we have some inverse proportion. So it says it takes 12 men 5 days to complete a job. Work out how many days it would take 3 men to complete the same job. So when we're looking at a question like this, if 12 men take 5 days, we just want to think about the logic as to the fact if we have 3 men doing the job, it is going to take a lot more days because we just have less people doing the work. So for this one here, I tend to find how long it would take one person to do the job, which would just be one man, and they would take 12 times longer. So although here we're dividing by 12, this is where inverse proportion comes in. Here we would have to multiply by 12. As one goes down, the other goes up. That's the very definition of inverse proportion, or the other way around. As one goes up, the other goes down. So here I'll multiply 5 by 12, and that would mean that one person would take 60 days. Now the question says 3 men, so we are going to get 3 times faster. So 3 men, and if we've multiplied on the left, we're going to divide on the right. So 60 days becomes 20 days. So our answer is 20 days. In this particular one, to be fair, 12 had a nice link with 3. As you are multiplying 12 by 4 to get 3 men, you could have actually just multiplied 5 days by 4, and that would have given you 20 days straight away. But that's not going to work for every question, but this one did have a really nice link between the 12 and the 3. So there we go, inverse proportion. It says, state one assumption you made in working out your answer. Well, we assume that the work rate of each person is the same. So we assume that they have the same skill. It's not that one person's going to change or take longer or slower or is less skilled. So we assume that they all work at the same rate. We'll just write that nice and quick. They work at the same rate. It says here, how will your answer be affected if your assumption is not correct? Well, if it's not correct, they could take longer or they could take less time. Okay, so they could take more or less time. There we go, more or less time. And there we go, that's how our answer would change if our assumption was not correct. Okay, onto some angles in polygons. So we're told here A, B, C, D, E, F, G, H is a regular octagon. As soon as it says regular octagon, straight away I'll be starting to work out the interior angle, but we'll carry on reading. ADJ is a straight line, which we can see there. So this line here is a straight line. And we have angle BAD is equal to angle CDA, which is also kind of highlighted on the diagram for us. We've got this one here is equal to this one here. Show that angle CDJ is 135. So CDJ is this angle here. Now when it says show that it's 135, we do not write 135 in there. So let's just imagine it's to find this angle. Now as long as via our working out we get 135, we're all sorted. Okay, but it can also almost help just to cross that out and then just see at the end if yours matches. So straight away, as soon as it said regular octagon, I want to make sure I get some marks here. So I'm going to work out the interior angle. So to work out the interior angle, we do the amount of sides, take away 2, which tells us how many triangles it's constructed of, and multiply that by 180. And that's going to tell us the sum of the interior angles. To work out one of those angles, well, as it's a regular octagon, we would divide by 8. And it would tell us the size of each of the individual interior angles. So 6 times 180, and again, this could be calculator or non-calculator. If it's non-calculator, you just do that using column multiplication, 6 times 0, 6 times 8, and 6 times 1, and get your answer, and then we're going to divide it by 8. So I'm going to type it in the calculator, 6 times 180, which comes out as 1080. And you would then divide that by 8, which you could do using bus stop, but 1080 divided by 8 is 135. Now that number there in this particular question might throw you off a little bit, because obviously it was asking us to show that an angle was 135, but that 135 is each of these interior angles within the octagon. That one at A is actually broken in two, so I'm not going to write that there, I'm just going to write it here and here. There we go, and again that one's broken up, so I can't write it there. So the next step here is to actually look at this shape. Now we can see that that is a four-sided shape. It is a quadrilateral. It might also be another type of quadrilateral, but at the moment we just know it's a quadrilateral. We know that the two base angles are equal. So if all the angles in a quadrilateral add up to 360, we've got 360 degrees. Take away the 235s, let's do 135 plus 135 in our working. So that is 360 take away 270. That leaves us with 90 degrees. Now, because the angles are equal, we can also divide that by 2. And that would tell us that each of those base angles is equal to 45 degrees. So this one's 45 and this one's 45. Now we're almost done. Now we've got the missing angles in that quadrilateral, we can think about what that angle is going to be on the outside. Now it told us in the question that this line here is a straight line. And we know that angles on a straight line add up to 180 degrees. So our final step to find this angle here would be to do 180, the angle's on a straight line, take away the 45 just next to it. And again, if you're wondering which bit we're looking at this total here on the straight line there. We know that part of it's 45, so 180 take away 45 would be equal to 135 degrees. So that would be 135 degrees. And there we go, we look back to the question, it did say show that it's 135 degrees, so we have done that. And again, notice how I've labelled my working out to the particular angles on the diagram. If you like to write things mathematically and you're happy to do that, you understand the way of writing it, then you can do that as well. So for example, where we did this 45 degrees, we could have written that as angle CDA. So CDA, and then written the working out next to that. But you don't need to do that, you can just label it on the diagram. But that does make it really nice and neat so you don't have to draw all over your diagrams. Okay, on to our next one. Right, so we have forming and solving an equation. So this one here says we have a rectangle. It says all measurements are in centimetres and the area of the rectangle is 48 centimetres squared. Show that y equals 3. So we have a very similar question here in that we have show that y equals 3. Let's just forget it says that. Let's just imagine it says find y. And as long as we get y equals 3, then we've definitely shown it. Now when we have forming and solving equations with a shape like this, where we're looking at side lengths, either we could be given the perimeter or we could be given the area. Now as it turns out, this one actually tells us the area. Now if we try to create an expression for the area, unfortunately we'd have two different letters because we know we do the width multiplied by the length, but we have two different lengths. So we'd end up with a bit of a mess there. But one thing that does stand out is that these two sides are the same, as we know for a rectangle. But for some reason, they've given us different algebraic expressions. So we can actually make an equation with those to find the value of x. So up to you which one you put left and right. I tend to put the bigger x on the left, but it really doesn't matter. 5x minus 9 is equal to 2x plus 6. From there, we can just solve this equation. So get rid of the smaller x from both sides. And that would leave us with 3x minus 9 is equal to 6. Then you can add the 9 to the other side. We're almost done. And you have 3x is equal to 15. And then the final step for solving this equation, we would divide by 3. And you get the value x is equal to 5. Now we know the value of x, we're not going to have that many unknowns because now we can substitute x into here. And 2x, if we write it out in full, would be 2 times 5 plus 6, and that would be a side length 16. You can sub it into the right as well, but it's a rectangle, so we know the left and right are going to be the same. But to be fair, in this question, subbing 5 in would be a good check just to make sure you've solved it correctly. Now this is quite similar to another question we've looked at anyway, because we are looking at now how to reverse this area. We know the area is length times width. So to find this width here, you would take the area, 48 centimetres squared, divide it by the length, which is 16, and that would give you the missing side length, which comes out as 3. So that little bit of working out there is our final step. It did say show that, so you'd probably put that down here as well. Just 48 divided by 16 is equal to 3. And then you could just write y equals 3 if you really wanted to make it really obvious exactly what you were saying. So there we go, we can get rid of that. Let's imagine it said find y, and we've ended up with y equals 3, so we've definitely shown it, and that is forming and solving equations. Okay, on to question 28. Amina has 2 bags. In the first bag there are 3 red balls and 7 green balls. In the second bag there are 5 red balls and 4 green balls, Amina takes at random a ball from the first bag, and then she takes at random a ball from the second bag. Complete the probability tree. So when we're looking at probability trees, each group of branches has to add up to 1. So this one here, where we have red and green, they have to add up to 1. The red fraction is 3 over 10, so the green fraction would have to be 7 over 10. Those numerators have to add up to 10 if the denominator is 10. On the next branches, we have different fractions, red and green again, but a different bag. So here, these two branches again have to add up to 1. We have 5 over 9, so this time it's out of 9, and the numerators have to add up to 9, so that would be 4. So there we go. It did actually tell us this information in the question. It did say 7 green balls and 4 green balls, but in all fairness, it was quite easy to fix that from the tree without that information. Now down here, this particular set of branches is the same as the one above. This is just the journey you'd go on if you took a green out of the first bag. So in the second bag, nothing's changed. It would still be 5 out of 9 in the second bag, or 4 out of 9. It now says work out the probability that Amina takes 2 red balls. So the journey that you would go on to take 2 reds would be going through this 3 over 10 and then going through this 5 over 9. And when you're going across a tree diagram, you just have to multiply what you go through. So 3 over 10 on the first pick, multiplied by, I believe it was 5 over 9 for red on the second bag, and 3 times 5 is 15, 10 times 9 is 90, and there's your final answer. Now you can write any equivalent fraction to that, so you feel free to simplify it if you want, but just be aware that if you simplify that incorrectly with probability, you are going to lose a mark. You are not going to lose any marks for writing it as 15 over 90. So absolutely fine for you to leave it like that. You're not going to be asked to simplify your answer in probability. If you are, obviously that's when you know to simplify it. Okay, on to the next question. We have a simultaneous equation. And we've already done a bit of a simultaneous equation, but this one has some negatives in there. Obviously we did one very early on in the paper. So we want to make the coefficients the same. Now this is a different type of simultaneous equation to earlier, which is why I've included both. This has different signs. So depending on which coefficient you make the same, some people will spot that this is the same and will do a subtraction. Although I do tend to find that when people do that, they make a lot of mistakes, particularly when there's negatives involved. Or some people are going to have a look at the coefficients of y and make those the same. Now, if you already know this very well and you want to take the approach of doing the x coefficients, feel absolutely free to do so, but I'm going to stick to the method that I always use, which is to make the coefficients of y the same. So I'm going to times the top one by 4. So that would mean the top equation there becomes 12x plus 4y is equal to negative 16. Now I'm going to take these two equations, I'm going to ignore this one now, and because they have different signs, we add them together. So 3x and 12x is 15x, negative 4y and 4y cancel out, and negative 16 add 6 is negative 10. I now need to divide by 15, so I get x is equal to negative 10 divided by 15, and I get a fractional answer, which is absolutely fine, although I would want to simplify this fraction because we need to sub it back in to find y. They both divide by 5, so it's a really nice one to simplify if you can get to this point. 10 divided by 5 is 2, and 15 divided by 5 is 3. So x is equal to negative 2/3. So a really nasty question here. This could be calculator, but it could also be non-calculator. So we don't want to rely on a calculator method on a question like this. Now when I sub that value back in, it doesn't really matter which equation I substitute it back into. You could choose to avoid the one with the negatives and sub it into the top one, but that one has a negative. The second one has a negative in the middle anyway, so it doesn't really matter here. I'm going to sub it into this one just because I tend to always sub it back into the first. So sub x equals negative 2/3 into there. So that gives us 3 lots of minus 2/3 plus y is equal to negative 4. Now I would hope, to be fair, a question like this would only come up on a calculator paper, but you never know, so let's figure out how to work this out. Now 3 times negative 2/3, whole numbers will only ever multiply the numerator, so that would just become minus 6/3 plus y equals negative 4. Again, you could write that as a fraction, 3/1, then just times the top times the bottom. Minus 6/3 is minus 2. 6 divided by 3 is 2, isn't it? So minus 2 plus y equals negative 4. Add the 2 to the other side. I'm going to write that in because we don't want to mess this step up. So there we go. Y would equal negative 4 add 2, which is negative 2. There we go. I was saying the answer before I'd even got there. So there we go. There are your answers. You have x is equal to negative 2/3, and you have y is equal to negative 2. And there are our answers. There we go. This particular question has given us a dotted line to write it on, so we would just write negative 2/3 for the x and negative 2 for the y. Obviously that question there was a lot harder than the simultaneous equation that we had earlier in the paper, but I thought it would be important to throw in a difficult one because, you know, this level of challenge can come up on one of these questions. Okay, and I think this is going to be our final question, and this is surface area of a cylinder. Yep, and this is our last question, so well done for sticking through. Maria has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 and a height of 1.8. Maria has 7 tins of paint. Each tin of paint covers 5 meters squared. Has Maria got enough paint to cover completely the 3 tanks? So we have this tank here, and there are 3 of them. She has 7 tins of paint, and each tin of paint covers 5 meters squared. Well, to be fair, we can work out straight away from that 7 times 5 would mean she has enough to cover 35 meters squared. So actually all we need to do is figure out, are 3 of these tanks going to be more or less than 35, and then we can obviously say whether she's got enough paint. Now we are looking at surface area, which is a lot trickier than volume of a cylinder. Volume of a cylinder, you just do pi r squared for the area of the base, and then multiply it by the height, and that will give you the volume. So much quicker than surface area. Surface area though, we have 2 circles, so we have pi r squared, we've got 2 of those, and you've also got the bit wrapped around the outside. And if we kind of draw this, we have a circle on the top, we have this kind of rectangle that's wrapped around it, this is kind of like a net of a cylinder, and then you also have this circle on the bottom, bit of a pain to draw. Now the circles have a diameter of 1.6, although straight away, whenever I'm looking at circles and I want the radius, I'm always going to write that in straight away. So that has a radius of 0.8. So that circle's not too difficult to work out. You also have another radius down here of 0.8. What else do we have? We've got a height of 1.8. And then we've got the nasty part. And the difficult part on a cylinder is that length there. And if you look, that length would be wrapped around the outside of the circle. So this missing length we're looking for here is actually the circumference of the circle. So you need to know your formulas very well. Circumference of a circle, let's just put area equals pi r squared next to that part there. The circumference of a circle though is pi times diameter, or pi times 2r, whichever one you're used to using. So pi times diameter will give us the width. Now the diameter of the circle is 1.6, so we did actually need the diameter anyway. So to work out that length, you'd do pi multiplied by 1.6. This is obviously a calculator question, so I'm going to type it into the calculator, as I don't unfortunately know 1.6 times pi. But it comes out as 5.0265 and a few more decimals. Now we're looking at whether we're going to be able to cover it with paint, so we don't need to work out the exact area, we're just going to get it as accurate as we can. So there we go, that's all the lengths that you need. From here, as long as you know the formula for the area of a rectangle, length times width, and the area of a circle, which we've written down just here, we actually just need to work those 3 things out. So if we start with the circle, area of the circle is going to be pi multiplied by the radius, which is 0.8 squared. Let's type that in. So pi times 0.8 squared. And that gives us an area of the circle of 2.0106, some more decimals, and we have 2 of those. So I may as well, before I delete that off my calculator, multiply it by 2. So times 2, and that gives us 4.0212. And there we go. What were the units? It was in meters, so that's going to be meter squared. That's for the 2 circles. Then we also have, let's just draw the 2 circles, and then let's draw the rectangle here so we know which bit we're doing where. The rectangle, the area is length times width, so 1.8 multiplied by the 5.0265, 1.8 multiplied by 5.0265, and that comes out as 9.0477 meter squared. So we have those 2 numbers there. We've got the 2 circles and the rectangle, and we need to add those 2 together. So let's write the total. There you go, you could show that working out. I'm just going to add it on my calculator quickly, 4.0212. And that comes out as a total area of 13.0689 meter squared. Now, of course, this question said that there were 3 of these tanks. So now we have the total surface area of 1 tank. We now want to multiply that by 3 tanks. So again, I'm just going to put times 3 tanks so we remember where that 3 came from. So times 3 on my calculator, and that gives us a total for the 3 tanks of 39.2067 meters squared. Now back to that first line in the question, we know that Maria only has 35 meters squared. So has Maria got enough paint to cover completely the 3 tanks? You must show how you get your answer. So we would say no. Maria has 35 meters squared worth of paint, or she can only cover 35 meters squared, and we need is not spelled with an M, let's write that again, and we need 39.2067 meters squared. Okay, and that's backed up by this working. Right, so there we go. That is the last question on the paper. Obviously, as we already mentioned, there are more questions on here than you get on a paper, but the nature of this one was to make sure we got a full coverage of all of those topics across the revision checklist. So don't forget to check out all of the links in the video. Everything's there. You can use everything for your revision. Don't forget to go on to the TGMT Hub and check out your free trial of the TGMT Upgrade program. But otherwise, don't forget to leave me a comment, don't forget to like the video, don't forget to subscribe, and I will see you for the next one.